Hello guys, today I'm going to be showing you how to install Mount River Studio, which is the default IDE when you are working with the WCH chips. So the first thing that you want to do when you want to install Mount River Studio is you want to open your browser and you want to type mountriver.com, and then you want to go to downloads and you want to choose your operating system. In this case, I'm using Windows, and you want to download the setup. So I've already finished downloading, and I will see you when you are done. Once your download is done, you simply go to your downloads folder, and you have the setup here, and we will extract the setup. Now, this is a standard installation, so there are no special permissions or anything, so you can simply go ahead with the installation. And whilst it's installing, I'm also going to show you how to get additional documentation when you're working with WCH chips. So whilst it's installing, you want to open your browser again, and you want to go to GitHub. Inside GitHub, you want to search for OpenWCH. And if you go to users, you should find the WCH official GitHub profile. So I will be sharing download links in the video section below, so don't worry. But once you go to their webpage, and if you check repositories, you want to see which chip you're working with, and then download the corresponding supporting files. So in this case, we're working with the CH32V307. And if you see the readme.md file, you get a simple overview of the chipset and how it's being used. So we're simply going to download the zip file so that we can get everything from the data sheet to some examples. Now, if you go to your downloads, this is the main documentation and all the files needed. They're in this GitHub repository, so we will extract it also. And I'm going to show you what's inside and how you can use some of the files inside this repository. So the main thing we're going to be trying to do today is we're simply going to run a GPIO toggle program, or more famously known as Blinky, to see if we can flash an LED on or off. So if you open this, you want to go for EVT. And inside this EVT folder, there are two subfolders. Pub folder for publications, or evaluation board manual and all other supporting documentation. And in here, the exam folder, it contains examples. So as you can see, the way the examples are listed, depending on the peripheral you're using or the system you want to run, then inside each folder, there are subdirectories. So for example, if we open the SPI folder, depending on how you want to use it, then you can load a single project and you can try running a sample one. So for us, we want to drive the GPIO pin. So we'll go to GPIO, and there's one subfolder, GPIO toggle. So this is the one we're going to try to run. And at the end of the video, I'm going to show you how to simply connect the board and run an LED on or off. Okay, so now that our IDE has finished installing, we're going to run the Mount River Studio, and I'm going to show you how to load a project once everything is done. Okay, so the program has finished loading, and as we can see in the welcome page, it's a pretty standard GNU-based IDE. So we're going to open one project, and we're going to download and debug this code. So if we go back to our downloads, we have GPIO toggle. We're simply going to select GPIO toggle, this project file here, and it's going to be automatically loaded into our IDE. If we go to user main, we should see the written code for this program, which is toggling a GPIO pin. So for now, what I'm simply going to do is I'm going to zoom in for readability. And if we take a look at the sample code, we can see that it's a GPIO pin A, GPIO A pin 0, which is going to be toggled on or off. And if we enter to the inside the main function, we can see this is going to be done after a delay of 250 milliseconds. So right now what I'm going to do is I'm going to rebuild this project. And then if you're downloading it for the first time, you need to go to configuration and make sure you have the right chip selected, the MCU, make sure you have the right MCU type selected. So I'm working with 307, CH32V307, so it's under the 30X family. And also browse in the OBJ folder, you want the corresponding hex file as well. And then you apply and close. And then you download. And that's a successful download. So that's pretty much it for running this program. At the end of the video, I will show you how to connect the pins, but from the basic main GPIO toggle init function here, we know that we are going to be driving GPIO A pin 0 on and off. So it's simply a matter of connecting pin 0 to the LED or any LED in order to turn it on and off. So now the next part I'm going to show you is how to do some basic debugging. So the first thing you want to do is, since it's your initial debug, you want to go to debug configurations and you want to select GDB open or CD. And upon selecting it, it will begin to load the debug view. So inside the debug view, you have your common debug views, the disassembly view showing you the machine code generated, variables, expressions, and registers. So the first thing we'll do is we want to go to our main.c file and we want to insert our breakpoints. So for this one, I'm going to set a breakpoint, a GPIO write bit function here. And then I'm going to run up to that breakpoint. Now, upon reaching the breakpoint, you can see the variables section has changed and it's showing us one variable in particular, x is equal our I variable. And if you select on it, you can get further information about it. And to the right, you have the disassembly view for the code about to be executed. Now, if we step into the function, that means that we are going to start to be debugging GPIO write bit. So it's going to show us where this function is written, the corresponding C file, and also it's going to load its variables into our variables view. Okay, so as we can see here, it has opened the CH32V307 GPIO.c file, which contains most of the functions for GPIO related manipulation. And if we scroll up just a little bit, we can see it's the function in our main.c file, which is now being debugged, and all its variables are now being showed in our expression in our variable window here. And we can expand these variables to see all the information and arrays contained within them and their corresponding values. As you continue to step into the code, it will step into the GPIO write bit function, and upon finishing, it will go back to main.c. Now the cursor is at the delay milliseconds function, and if we step into it, it will repeat the same routine. It will open the .c file containing the function, and then if you scroll up a little bit, you can see this is the function, and as you step into it, the variables, they will change and you can monitor them from here. So as long as if you continue stepping into the function, you should see how your code is being executed, and after each function, it always goes back to the main.c folder and the cycle repeats again. So that is it for debugging. Okay, so I hope you enjoyed this quick start into how to work with WCH chips. So this is just the beginning. I'm going to be uploading more videos soon and also showing you slightly more complicated stuff and a lot more that you can do with WCH chips. So if you have any questions, please feel free to ask them in the comment section below. I'll be more than happy to assist you. So that's it for today, guys. If you have any questions, please feel free to ask me in the comment section below. I will include download links for all the necessary documentation and any source code you might need. And if you need anything WCH related, please don't forget to ask in the comment section below. We are more than happy to help. Goodbye.